Now the cross product. Cross product of two vector u cross v. The cross product is denoted by x or can be denoted of that form. Both are the same. U cross v is not a number, it's a vector. So if you have here vector u, as you can see, and vector v, so you're going to get a vector perpendicular to v and u, and it's normal, and it means normal to vector u and v, and the length of this vector is absolute value of u times absolute value of v times sine angle in between. This is the length times the unit vector of its normal, and a vector n here is perpendicular to u and v. So to know the direction, if it's up or it's down, if you have u dot v, you put your hand here on this intersecting point, your thumb is up, and you cross your fingers. If the vector v is towards your finger crossing, it will be up. However, here if you want to do v cross u, if you put here your hand here, if you put your hand here and towards vector v, and if you cross your finger, as we said, v is not towards inside, it's towards opposite of the crossing finger, so the vector will be down. So always, if the vectors are parallel, we know that sine 0 or sine 180 is 0, so it means the u cross v is equal to 0. So when u cross v is 0 and the vectors are parallel. If u and v and w are any two vectors, if you multiply r by s, you can put it outside. V cross u is minus u cross v. 0 cross u is 0. Here you have the distributive property u cross v plus u cross w. Here vector plus vector is vector, and cross of two vector is a vector. Here v cross u plus w cross u. U cross vector cross a vector is a vector, and vector cross a vector is also a vector. So it will be, if you have the cross here, this is the formula, it will be u dot w times v minus u dot vw. We're not going to use this one, so don't look at number 6. This is more we used in the Analytical program. Now we have three-dimensional OIJK instead of using the hand rule. So if you have I cross J, instead of putting your hand here on I, you can put your hand here on I, and you close it here. You can see that J is towards the closing hand, so it's K. Instead of doing the hand rule, if you have IJ directly, IJ, you get K. If you have JK directly after it, what do you get? I. If you have, for example, IK, you have KI. KI will give you J, but IK will give you minus J. Okay, so IK, because why? It's not direct. KI, J. However, IK will give you minus J. If you have J, IJ will give you K, but JI you're moving opposite. JI will give you what? Minus K. If you have here, for example, this is A, you have AB, this is AB, this is AC. Let me draw another one. So here you have, so use this picture, not this one. If you want AB, AC, directly after it, what do you get? The perpendicular AD. If you have AC, AD, AC, AD, you return back to AB. If you have AD, AB, then directly AC. If you have AC, AB, here AC, AB, AC, you're moving backward, you're going to get minus AD. So AC, AB. So this is for direct. BA, AC, BA, because I need to start by A. If you switch it, it will be minus, you put it. AB, AC, AB, AC, directly it will be AD, and you have minus. AD, CA, it will be AD minus AD, AC, because you need to switch. If you do AD, AC, AD, AB will give you AC. AC, AD will give you AB. But AD and before it AC, it will give you, I'm moving opposite, it will give you minus AB, and you have minus, it will be AB. So this is instead of using the hand rule. Now if I want to find this the norm of u cross v, so it's norm u norm v sine theta. We add to it norm of the perpendicular. Here the norm of the perpendicular is 1, so it's u v sine theta. We know that sine theta here is equal height over norm of v. So what will be the height? It will be v over times sine theta. So v sine theta here is the height times vector u. You know, if you have a parallelogram, two vectors u and v, the height times u, it will be the area of the parallelogram formed by the vector u and v. So what is this, the norm of a cross product? The norm of a cross product u cross v is nothing else in norm the area of the parallelogram formed by the two vector u and v. Okay, now we're going to find the determinant form of u cross v. If you want to, you have in scalar component form u1i, u2j, and v1i, v2j, etc. So we need to find u cross v. If you do u cross v here, you're going to get u1 v1 i cross I, u1 v2 ij, etc. You have all of these here. Now we're going to study here to get the answer. So as we can see, let me repeat this one. So if I want to multiply here, I and I is 0, ij will give you k, ik it will give you its opposite minus j, ji it will give you minus k, jj is 0, jk it will give you I, ki it will give you j direct, kj its opposite minus I, and kk is 0. You have this form at the end. So directly this is the matrix ijk, unit vector u1, u2, u3, v1, v2, v3, and the determinant of the matrix, what do? You start by, you put here plus, minus, plus. So this is components vector u cross vector v. So you start I, you cross row and column, it will be u2 v3 minus u3 v2 minus j into u1 v3 minus u3 v1 plus k into u1 v2 u2 v1. Let us take an example. The hand rule, you're not going to use it anymore, just to tell you no, the cross product is a vector and the direction. Suppose you have two vector u and v. Suppose I told you find the vector u cross v, so you put ijk, u and v. So you start, you cancel row and column. We have first of all I, cancel row and column. You multiply this one time this one minus this one time that one. So it will be 4 minus 0. And if you then you go to j, the middle one you put minus j, cancel row and column. So it will be minus 1 times 2 minus 3 times minus 1 plus 3. And then plus k, cancel row and column. You have these 4. So it will be minus 1 times 0, which is 0, minus 2 times minus 1, which is plus 2. So you have a vector whose components are 4, minus 1, and 2. And if I tell you I want the area of the parallelogram formed by u and v, as we said, it will be square root of 16 plus 1 plus 4, which is square root 21. Now if find u cross v and v cross u, if u and v, u cross v is opposite of v cross u. So ijk, you put u, you put v, so you start I. Okay, we do 1 minus 3, 1 minus 3, which is minus 2, then minus j into, you have this 4, so it will be 2 plus 4, 2 plus 4, 2 plus 4, this is 5, not minus 6, 2 plus 4, so minus 5. And the k, you're going to cancel row and column, so it's 6 plus 4, which is 10. So u cross v is minus 2, minus 5 here, and 10, and v cross u will be the opposite, 2, 5, and minus 10. Find the area of triangle formed by the two vectors here. So what do? We do u cross v. So ijk minus 2, 3, 1, and minus 3, 2, 2. So I cancel row and column, it will be 6 minus 2, minus j cancel row and column, minus 4 plus 3, and k cancel row and column, minus 4 plus 9. So it will be 4, 1, 5. So what do? Area of parallelogram, it will be square root of 16 plus 1 plus 25, which is square root 42. And the area of triangle is half the area of the parallelogram, it will be square root 42 over 2 unit